Resistance is one of the crucial components that make up Ohm's law. They are a critical piece in just about every circuit, and today we will discuss what is a resistor, identifying a resistor, and most importantly, applications of a resistor. Okay, so let's begin. Resistors are electronic components which have a specific, never-changing electrical resistance. Their resistor's resistance limits the flow of electrons through a circuit. They are a passive component, meaning they only consume power and cannot generate it. Resistors are usually added to circuits where they complement active components like op-amps, microcontrollers, and other integrated circuits. Commonly, resistors are used to limit current, divide voltages, and pull up input-output lines. Resistors are measured in ohms, and 1 ohm can be quantified as 1 volt of potential energy pushing 1 ampere of current through a circuit. Don't worry about all that mumbo-jumbo for now, but it's important to identify resistors in circuit diagram, PCB boards, and service manuals. Resistors are typically symbolized as a zigzag or square-shaped sign with its value denoted on top of the symbol. If you may not know, resistors come in either through-hole technology, surface mount, static non-changing, package type, or special variable resistors. Static non-changing resistors can be identified by a standardized color code. For example, in a 4-band resistor, the first 2 bands indicate the 2 most significant digits of the resistor's value. The 3rd band is a weight value, which multiplies the 2 significant digits by the power of 10. The tolerance explains how much more or less the actual resistance of the resistor can be compared to what the normal value is. No resistor is made to perfection, and the different manufacturing processes will result in better or worse tolerances. For example, a 1 kilo ohm resistor with a 5% tolerance could actually be anywhere between 0.95 kilo ohms and 1.05 kilo ohms. How do you tell which band is first and last? The last tolerance band is often clearly separated from the value bands, and usually it will be either silver or gold. 5 and 6 band resistors have a 3rd significant digit band between the first 2 bands and the multiplier band. 5 band resistors also have a wider range of tolerances available. 6 band resistors are basically 5 band resistors with an additional band at the end that indicates the temperature coefficient. This indicates the expected change in resistance value as the temperature changes in degrees Celsius. Generally, these temperature coefficient values are extremely small. When decoding the resistor color band, consult a resistor color code table like the one below. Series and parallel resistors. Resistors are paired together all the time in electronics, usually in either a series or parallel circuit. When resistors are combined in series or parallel, they create a total resistance, which can be calculated using one of 2 equations. Knowing how resistors value combine comes in handy if you need to create a specific resistor value. Series resistors. When connected in series, resistance simply adds up. So, for example, if you just have a 12.33 kilo ohm resistor, seek out some of the more common resistor values like 12 kilo ohms and 330 ohms and put them together. Parallel resistors. Finding the resistance of resistors in parallel isn't quite so easy. The total resistance of the resistors in parallel are the inverse of the sum of all the resistances. This equation might make more sense than the last one. Here are a few examples of circuits which heavily depend on our resistor friends. Let's talk about the LED current limiting resistor. Resistors are key in making sure LEDs don't blow up when you power them. By connecting a resistor in series with an LED, current flowing through the 2 components can be limited to a safe value. When sizing out a current limiting resistor, look for 2 characteristic values of the LED: the typical forward voltage and the maximum forward current. The typical forward voltage is the voltage which is required to make the LED light up, and it varies, usually between 1.7 volts and 3.4 volts, depending on the color of the LED. The maximum forward current is usually around 20 milliamps for basic LEDs. Continuous current through the LED should always be equal or less of that of the current rating. Once you have gotten hold of those 2 values, you can size up the current limiting resistor, which is this equation. Okay guys, I'm going to cut the video over here. I didn't really want to make it too long or too complicated. This is just a basic video about resistors and all that kind of stuff. Please do check out the link over here. But I probably have a playlist about all the other basic electrical stuff, like from capacitors and all that kind of stuff. And please, if you do like videos like this, please do comment, please do hit a like and subscribe so I know to make more videos like this in the future. Again, so sorry for the long delay of making videos. I've been busy. I've been in and out of town and I only got back now. So again, comment in the section. Just let me know if you guys are interested in this and then we'll be easy. Check in the next one.